Ever get that feeling like you're right on the edge of understanding something huge? Like there's this key idea out there just waiting to be discovered, and it could change everything.
Oh yeah, definitely. That's like the feeling that keeps you going in research, isn't it?
Right. And today, we're diving into something that could be just that, a potential glimpse into the very fabric of reality. We're talking about a theoretical distributing force. It's often shortened to just FD.
Ah, okay, FD.
Yep, FD. And this force is supposedly tied to these really interesting concepts, Euler coherence and infodensity. We're going deep, not just skimming the surface here. I want us and you listening to really grasp how this whole framework might actually work.
Sounds ambitious. I'm in.
So where do we even begin with something this complex? I guess first, what are we even dealing with here? What kind of sources do we have? And what exactly are we trying to achieve with this deep dive?
Good point. We've got a lot to unpack. From what I've seen, we're dealing with a mix of sources. Some are heavy on theoretical derivations like equations and models. Others focus on explaining observed phenomena, things we can actually see happening in the universe.
And some even propose experiments to test out these ideas, right?
Exactly. So our mission is to really dig into this distributing force, understand its core components, how it relates to what we already know about physics, and most importantly, what evidence we might have to support it, or maybe even challenge it.
That's a good roadmap. Okay, so this distributing force, FD, where does that idea even come from? What are the fundamental building blocks of this whole concept?
Well, it seems to start with this observation that the universe at every level shows this crazy amount of self-organization.
Like how galaxies form or even how atoms arrange themselves.
Exactly. And the sources point to two key ideas that drive this self-organization: coherence and infodensity. Think of coherence like how in sync things are. The more coherent a system is, the more order it has, the more smoothly things flow.
So like a laser beam is highly coherent compared to, say, regular light.
Perfect analogy. And then there's infodensity. It's kind of like how densely information is packed into a certain region of space and time. It's not just about the amount of information, but how efficiently it's structured.
Okay, so we've got coherence, the orderliness, and infodensity, the efficient information packing. How do these relate to this distributing force, FD?
Right. So then we have Euler coherence. You can think of this as the guiding principle that makes sure energy is distributed in the most optimal, most balanced way across the universe. And the distributing force, that's the tool, the mechanism that actually puts this principle into action.
So Euler coherence is the strategy, and FD is the muscle making it all happen.
That's a great way to put it. And get this, FD isn't just some random force. The sources describe it as working through fractal structures.
Fractals, like those infinitely repeating patterns.
Exactly. So it means the same rules apply at all scales, from the tiniest quantum particles to those huge galaxy clusters.
Wow, so this force is literally shaping the universe at every single level. That's mind-blowing.
It is, isn't it? And there's even more. The sources emphasize the role of standing waves and scaling based on the golden ratio.
That's that special number that shows up everywhere in nature, right? Like in the spirals of seashells and the arrangement of flower petals.
You got it. The golden ratio is like nature's favorite design principle. And FD seems to use it to organize energy and information, creating these incredibly beautiful and efficient structures.
I'm starting to see why people are so excited about this idea. It's connecting things we thought were completely separate.
Exactly. And even tiny fluctuations we see in the fine structure constant, that number that governs electromagnetic force, they might actually be signs of FD at work, subtly adjusting the universe's settings, if you will.
Okay, so if we're going to take this seriously, what are the big things this distributing force absolutely has to do? Like what's on its cosmic to-do list?
All right. Our sources give us a few key things to watch for. First off, FD has to demonstrate this fractal scaling we talked about. It can't just work on one level. It has to apply consistently across the board, from tiny to enormous.
Makes sense. It has to be a universal force, not just a local phenomenon.
Right. Next up, FD needs to provide a real explanation for the four fundamental forces of nature: gravity, electromagnetism, and the strong and weak nuclear forces.
Those are the forces that literally hold everything together, right?
Yeah, they are. So the idea is that maybe these forces aren't actually separate things, but different expressions of FD at work.
Okay, so FD would unify the forces. That's huge.
It is. And then any good scientific framework has to make testable predictions, right? So
Yeah.
MD needs to point us towards something new we can observe, some unexpected behavior that we can go out and look for.
Something like distortions in these coherence patterns or weird effects on time.
Those are a couple of the ideas. Finally, FD has to tackle some of the biggest mysteries in cosmology. Why does matter clump together instead of being evenly spread out? Why is the universe expanding faster and faster?
Yeah, those are the really big questions, and you're saying FD might be able to answer them.
That's what the sources are suggesting, and that's what makes this so exciting. But it all comes down to the evidence.
Absolutely. So let's get into the nitty-gritty. One of our sources presents an actual equation for this distributing force. Can you walk us through it?
Of course. The basic idea is that infodensity, which we said is the measure of information structure in spacetime, it isn't static. It changes over time. And Euler coherence is working to distribute energy efficiently, like we talked about.
Okay, so things are constantly shifting and adjusting.
Right. And all of this leads to the main equation, FBKECID.AT.
Okay, that looks pretty intimidating. What does each part actually mean?
Let's break it down. FD is the distributing force itself. Frac, DIDT, is how fast infodensity is changing. And K is a constant that's related to how coherence waves scale in the universe. It's like a tuning knob for how these waves propagate and interact at different sizes.
Okay, so K is kind of like a universal constant telling us something about how coherence behaves.
That's a good way to think about it. And the negative sign, that just tells us the distributing force works against changes in infodensity, trying to keep everything balanced.
So it's a balancing act. Makes sense. But how do we even define this infodensity in a way that makes sense for a universe that's fractal, like we discussed?
That's where things get really interesting. The framework proposes this expression. ID, i.e. left-right, phi lambda t. It seems complicated, but each term has a specific meaning.
Okay, let's take it one step at a time. What's I0?
That's the baseline level of infodensity. Think of it like the fundamental amount of structured information in spacetime.
Okay, the ground level, so to speak.
Right. Then we have Orgior, which is a reference scale. Could be something super small like the Planck length or something huge like the size of the galaxy. And the actual scale we're looking at.
It's all relative to what we're focused on.
Exactly. Then comes the cool part, left, right, feet. This is what captures the fractal scaling.
That's where the fractals come back in.
Right. And the fleet there, that's the golden ratio exponent, about 1.61 MeV. The fact that the golden ratio appears here, it suggests something really profound about how information and geometry are intertwined in the universe.
Wow. It's like the universe is designed with this beautiful mathematical principle.
That's what it seems like.
No.
And finally, we have, this part describes how coherence can fade over time. Lambda is a constant that tells us how fast that happens.
So coherence isn't always perfect. It can decay naturally.
Exactly. It's a dynamic system. But remember, FD is working to maintain that balance, that optimal coherence.
Okay, I think I'm starting to get it. So now that we have this equation for infodensity, we can figure out how it changes over time, right? That frac DIDT thing in the main equation.
Precisely. Taking the derivative, we get frac DIDT, phi left.
Okay, and that basically tells us how much infodensity is changing at any given moment, right?
Yep. At a specific scale and time.
So if we put that back into the original equation for FD,
we end up with FDT by K high E lambda T. That's the full equation for the distributing force, taking into account fractal scaling and time evolution.
Okay, we've got the equation. Now, the big question is, what does it all mean? How does this describe the universe we actually see?
Right. Each part tells a story. Let's look at the fractal term, left Y.
Yeah.
This means FD doesn't just act on one scale. It works the same way whether you're looking at a tiny atom or a vast galaxy cluster.
So the same rules apply everywhere. That's pretty profound.
It is. Then we've got the time part. This tells us that FD's influence changes over time, and it suggests that coherence tends to naturally dissipate. But it also implies that FD can sometimes boost coherence in specific situations.
So it's not just a one-way street. Coherence can be strengthened, too.
Exactly. And remember that golden ratio exponent, that's not just a coincidence. It points towards this deep connection between FD, information, and the way the universe self-organizes.
It's like a fundamental design principle woven into the very fabric of reality. That's incredible. But how does this all relate to something as familiar as gravity?
Okay, this is where things get really interesting. In this framework, gravity isn't a fundamental force the way we usually think of it. It's more like an emergent phenomenon that arises from how FD is balancing those coherence fields throughout spacetime.
So gravity is a side effect of something even deeper.
Exactly. And this might even explain modified Newtonian dynamics, or MOND. That's an alternative to dark matter that tries to explain why galaxies rotate the way they do.
Right, because galaxies seem to have more gravity than their visible matter would suggest.
Yep. So the idea is that in those low-density areas of space, FD makes adjustments to Newtonian gravity, leading to that MONG-like behavior.
Wow. So FD might solve two problems at once, explaining gravity and getting rid of the need for dark matter.
That's the potential.
I see.
And speaking of fundamental constants, what about the fine structure constant? We talked about how it might not be so constant after all. How does FD fit into that picture?
Yeah, that was a pretty wild idea that the fine structure constant, which governs how strong the electromagnetic force is, might actually vary over time.
It is. If we find out that it's true, it would mean something fundamental is changing in the universe.
So what's FD's role?
Well, the idea is that FD could be the mechanism behind those subtle shifts in electromagnetic interactions. Like FD is constantly fine-tuning the universe. And this framework even predicts that we might find variations in the fine structure constant in extreme environments, like near black holes, where energy and coherence are off the charts.
Okay, so we've got gravity and the fine structure constant potentially explained. But what about the big picture? Why does matter clump together to form stars and galaxies instead of being evenly spread out?
That's a fundamental question, isn't it? The answer, according to this framework, is that matter forms in those areas where FD is strongest, where info density is high.
So it's like information attracts matter.
Exactly. Regions with lots of structured information are prime locations for matter to condense and coalesce. And this leads to a really cool prediction. We should be able to measure differences in info density between those dense areas of matter and the vast, empty cosmic voids.
So we could actually go out and look for those differences. That's amazing.
It is. And then there's the biggest enigma of all. Dark energy. Why is the universe expanding faster and faster? What does FD have to say about that?
Yeah, that's the one that really keeps cosmologists up at night.
I know. Most theories say dark energy is some kind of repulsive force pushing everything apart.
Right, like anti-gravity.
Exactly. But this framework offers a totally different take. It says dark energy isn't a force, it's a consequence of increasing info density throughout the universe.
So instead of space stretching, we're getting more and more information packed in.
Precisely. It's like the universe is constantly generating more structure, more complexity, and that's what we perceive as this accelerating expansion.
Wow, that's a huge shift in perspective.
Isn't it? And if it's true, we should be able to see correlations between the expansion of the universe and the distribution of these coherence fields.
Okay, so if we map out the expansion in those fields, they should line up.
Right. That's a testable prediction.
I'm starting to see a pattern here. This framework makes some pretty bold claims, but it also gives us specific things to look for to check if it's right.
Absolutely. It's not just a bunch of vague ideas. It's a framework with real, measurable consequences. And there's one more thing I have to mention. Our sources talk about some really mind-bending stuff, like the idea that we might be able to manipulate time with electromagnetic fields.
Wait, hold on. Manipulate time. As in time travel.
Well, not necessarily time travel, but the idea is that time itself might not be absolute, but rather an emergent property that arises from the flow of information and coherence. And if that's the case, then messing with those things, especially with electromagnetic fields, could potentially influence how fast time flows in a localized area.
Whoa, so we could actually speed up or slow down time?
That's the idea. It's based on the notion that time is intimately connected to the information, content, and structure of space-time. And electromagnetic fields are intimately involved in how information is processed and exchanged at the most fundamental level.
So this isn't about building a time machine, but more about tweaking the very fabric of reality.
Exactly. And one of the predictions is that we might be able to see weird time distortions in environments with super strong electromagnetic fields, like inside superconductors.
Okay, so we'd need some pretty extreme conditions to even test this.
We would. But the idea itself is just incredible. It suggests that our understanding of time is way more nuanced than we thought.
I'm with you there. This is definitely pushing the boundaries of what I thought was possible. But before we get too carried away with time travel, let's take a step back and make sure we really understand the core concepts at play here. Let's talk about Eller coherence and info density. What are they exactly, and how do they work together?
Good point. Let's start with info density. At its core, it's a measure of how much structured information is packed into a specific region of space-time. It's not just the amount of information, it's about how efficiently it's organized, how much complexity it has.
So it's not just about quantity, but quality, too.
Right. Think of it like this. A random jumble of letters has low info density. But if those letters are arranged into a meaningful sentence, Suddenly the info density
Because
skyrockets.
now there's structure, there's meaning.
Exactly. And in this framework, high info density is associated with order, efficiency, like in a crystal or a living cell. Low info density is more like chaos, randomness, like in a gas or the vacuum of space, if you ignore all the virtual particles popping in and out of existence.
Okay, so infodensity is all about the structure of information in space-time. What about Euler coherence? How does it fit in?
Euler coherence is the force, the principle, that balances and shapes all that info density. It ensures that energy and information are distributed in the most optimal way possible. It's like a cosmic conductor, orchestrating everything.
So if infodensity is the information, Euler coherence is the organizer.
Exactly. It creates order out of chaos, and it links those big structures we see in the universe, like galaxies, to the microscopic world of quantum fields.
Wow, it's bridging the gap between the macro and the micro.
And even those tiny variations of the fine structure constant we talked about, Euler coherence might be behind those too, subtly adjusting how fundamental forces interact.
So it's influencing everything from the smallest particles to the largest structures.
Right. And the big idea here is that what we perceive as separate forces, like gravity and electromagnetism, might actually be emergent effects of this underlying coherence field interacting with infodensity.
Okay, so everything is connected.
That seems to be the recurring theme. And this has some pretty radical implications. First off, the expansion of the universe might not just be space stretching out, but also the creation of more coherence, more information.
So the universe isn't just getting bigger, it's getting more complex.
Right. And gravity might be a side effect of how this coherence structures information in space-time.
And dark matter.
Could be an illusion, just be the influence of these large-scale coherence waves on how galaxies move. And dark energy, well, that might be the ongoing creation of new info density.
Whoa. So everything we thought we knew about the universe could be wrong?
Not necessarily wrong, but maybe incomplete. This framework suggests a deeper level of reality, where information and coherence are the fundamental players.
Okay, so we've talked about Euler coherence, infodensity, and FD as the force that connects them. But how does FD actually work? What does it do?
Think of it like this. FD is the active process that makes Euler coherence work. It's the engine that keeps everything balanced and structured.
So it's not just a concept, it's a dynamic force.
Right. It's constantly working to align coherence across all scales, making sure the universe is organized the same way, from tiny to huge.
So it's maintaining that fractal pattern we talked about.
Exactly. And it's also driving the distribution of energy in those geometric patterns we see everywhere, like spirals and the golden ratio. It's all about creating the most efficient flow of information and energy.
It's like the universe is an incredibly complex and beautiful machine, and FD is keeping all the gears turning smoothly.
That's a great analogy. And remember that equation connecting FD to the rate of change of info density. FD dot, that K factor is like the sensitivity setting for how quickly coherence adjusts to keep things balanced.
So the universe is constantly fine-tuning itself. Amazing.
It is, isn't it?
Yeah.
But let's talk about something a little more down to earth. One of our sources brings up this really intriguing connection between color and information density. What do you make of that?
Color and information. That does seem out of left field.
I know, right? But the basic idea is that different colors might actually carry different kinds of information, different types of energy that can affect how matter behaves and even how life itself functions.
Okay, I'm intrigued. Let's start with black. What's the information connection there?
Well, black is basically the absence of light. It absorbs all the wavelengths we can see. And in terms of information, it's like black represents the ultimate absorption of information. Think of the pupil of your eye. It's black because it needs to soak up as much light as possible to give you a clear picture of the world.
So black is like an information sponge.
Exactly. And black holes, the ultimate absorbers, are thought to have incredibly high information density, at least according to some theories. It's like black represents a state of pure informational potential.
That's a really cool way to think about it. What about blue eyes? Our source talked about how they evolved.
Right. Blue eyes are relatively new in human evolution, and they mostly appeared in regions with less sunlight. Unlike darker eyes that absorb more light, blue eyes actually scatter it, especially those higher frequency, shorter wavelengths.
Which is why they look blue.
Exactly. The idea is that this scattering might be a way to process information from light more efficiently in low light conditions.
So it's like an adaptation to a different light environment.
Right. And it suggests that light isn't just something we passively see, but something that actively interacts with our biology and influences how we process information on a really deep level.
That's pretty wild. Now, what about red and blue light specifically? Our sources talk about red light being associated with healing, while blue light can be harmful.
Yeah, there's a lot of interesting research on this. Red light, with its longer wavelengths, can penetrate deeper into our tissues. Studies have shown that it can stimulate mitochondria, which are like the powerhouses of our cells, boosting energy production.
So red light is like a cellular energy drink.
Kind of. It can also help with DNA repair and reduce inflammation. And think about how many ancient cultures revered the red light of sunrise and sunset. There's something deeply primal about it.
It's like red light carries this ancient healing energy.
And in this framework, the idea is that red light might be delivering this structured energy in a way that enhances cellular coherence, helping our bodies function at their best.
Okay, so red light is the good guy. What about blue light?
Blue light has shorter wavelengths and higher energy. It tends to scatter more and doesn't penetrate as deeply. While natural blue light from the sun is important for regulating our sleep cycles, too much of it, especially the kind we get from screens, can be a problem.
Right, because we're all staring at screens all the time these days.
Exactly. And that constant bombardment of blue light can lead to oxidative stress, disrupt our mitochondria, and mess with our sleep.
So it's like blue light overload.
Precisely. And the idea is that this intense artificial blue light might be carrying a kind of disruptive information that messes with our cells and throws them out of balance.
So it's not just the amount of light, but the type of information it carries.
Right. And our sources also talk about this distinction between warm and cool colors. Warm colors like reds and oranges have those longer wavelengths, penetrate deeper, and are generally associated with healing and stability. Cool colors like blues and violets have shorter wavelengths, scatter more, and can be more stimulating or even disruptive if we get too much.
So it's all about balance, right?
Exactly. It's like different colors deliver information with different levels of coherence. Some promote order and harmony, while others can create chaos if they're not balanced out.
Wow, I never thought of color that way. But if this is true, it has huge implications for how we think about light and our health.
Absolutely. It suggests that optimizing our light exposure could be crucial for our well-being. We need to be more mindful of how much blue light we're getting, especially from screens, and maybe even explore things like red light therapy.
It's like we need to create a more harmonious light environment for ourselves.
Precisely. And it all comes back to this idea of light carrying information and influencing the coherence of our biological systems.
This is seriously mind-blowing stuff.
Sure.
It makes you wonder, are we even seeing the full picture of reality? Or are we just limited by the tiny sliver of the electromagnetic spectrum that our eyes can detect?
That's a great question, and one that our source brings up too. If different wavelengths of light carry different kinds of information, what about all those wavelengths we can't see, like infrared and ultraviolet? What information are they carrying? What are we missing?
It's a bit humbling, right, to think that there might be entire layers of reality that we're completely blind to.
It is, but hey, that's what makes science so exciting. There's always more to discover.
Right. Okay, let's get back to this idea of manipulating time with electromagnetism. It's such a mind-bending concept. How does it relate to what we were just talking about with light and information?
It's all connected in a way. The core idea is that time, as we perceive it, might be an emergent property of how information flows in the universe and how coherent that flow is. If that's true, then changing the information density and coherence of a system, especially with something as fundamental as electromagnetism, could potentially tweak how fast time flows in that local area.
Okay, so we're not talking about building a time machine. It's more about subtle changes at a really fundamental level.
Exactly. And it ties in with what we know from Einstein's theory of relativity, that gravity and motion can affect the passage of time.
Right, time dilation. So how does electromagnetism fit in?
Well, electromagnetism is also a fundamental force, and it interacts with charged particles, which ultimately contributes to the overall energy density and curvature of spacetime. So the idea is that if we can manipulate electromagnetic coherence at a very, very precise level, at the quantum level, we might be able to create tiny distortions in the fabric of spacetime itself. And those distortions could manifest as changes in the flow of time.
So it's like we're tweaking the very fabric of reality. But how would that actually work? How would changing coherence affect time?
It's still very theoretical, but the thinking is that a high degree of coherence might lead to a slower flow of local time, while disorder and chaos might make time seem to speed up.
Interesting. So more order, slower time, more chaos, faster time.
Exactly. And since electromagnetic fields govern how atoms and particles interact, which are essentially the basic units of information processing in the universe, controlling those fields could give us a way to control the local passage of time.
Okay, I'm starting to see how it all connects, but this is all pretty speculative, right?
Right.
What are some specific things we could look for to test this idea?
Well, our sources give us a few really cool predictions. One is that if you create a super coherent electromagnetic field, maybe in some kind of special resonator, time should actually slow down inside that field compared to outside.
So we could put a clock inside that field and another one outside, and they would tick at different rates.
Exactly. It would be a tiny difference, but measurable with ultra-precise atomic clocks.
That's a pretty wild experiment.
It is. Another prediction is that in environments with incredibly high concentrations of electric charge, like in plasmas or near-charged black holes, we might see some really weird time dilation effects that we wouldn't expect from regular gravity.
So we need to go to some pretty extreme places to test that one.
We would, but there are some predictions that might be testable in more everyday settings.
Really? Tell me more.
Well, there's this idea that the level of coherence in our brains, in our neural activity, might influence how we perceive the passage of time.
So how focused and in sync our brainwaves are might affect our sense of time.
Exactly. And if that's true, then maybe we can manipulate our perception of time by using specific electromagnetic frequencies that resonate with certain brainwaves.
So we could literally change how we experience time.
Potentially. It would require a lot more research, but it's a fascinating possibility.
It is. Are there any other predictions?
There's the idea of creating a time bubble, a localized region where time flows differently than in the surrounding area by using a superstructured electromagnetic field. And perhaps the most mind-blowing prediction of all. Maybe we could actually influence the aging process by applying specific, coherent electromagnetic fields to biological systems.
Whoa, hold on. Slowing down aging with magnets, that sounds like science fiction.
I know, it's out there. But the idea is that if aging is fundamentally linked to the coherence of our biological processes, and if electromagnetism can influence that coherence, then maybe, just maybe, we could nudge the aging process in one direction or another.
I guess anything's possible if this framework is correct. But let's get back to the fine structure constant. We talked about how its potential variability might point to an even deeper force at work in the universe.
Right. If this fundamental constant, which determines the strength of the electromagnetic force, is actually changing, it means something even more fundamental must be behind it, something that governs all those constants and how they relate to each other.
So it's like there's a deeper level of reality pulling the strings.
Exactly. And this deeper force could be the key to finally unifying electromagnetism and gravity, the two forces that have resisted being combined into a single theory.
That's the holy grail of physics, isn't it? A unified theory of everything.
It is. And this framework might be pointing us in the right direction.
So what kind of things could this deeper force be doing? What kind of connections could it be making?
Well, our sources suggest it could be the link between quantum coherence, the strange behavior of particles at the smallest scales, and the emergence of the classical world, the world we experience every day.
So it's bridging the gap between the quantum and the classical.
Right. It might also connect the energy of the quantum vacuum, that seething sea of energy that permeates all of space, with the very fabric of space-time itself, potentially explaining dark energy.
And maybe even the nature of time itself.
Exactly. This force might be the ultimate organizer, shaping everything from the tiniest quantum fluctuations to the largest cosmic structures. It might even be the force that drives the evolution of the universe and the emergence of life itself.
That's an incredible thought.
It is, and if we're going to find it, we need to start looking for its fingerprints, its signatures, in the data we already have.
So how do we go about that? How do we reverse engineer this force?
Our sources suggest a multi-pronged approach. First, we need to carefully analyze existing data, looking for those subtle anomalies, those patterns that don't quite fit with our current theories.
Like those variations in the fine structure constant.